All right, in this video, we're going to look at how to solve linear systems word problems, and we're going to do it algebraically, so we're not going to use a graph to help us get our answers here. And let's look at our first problem. So Maya's working 2 summer jobs. She makes $7 per hour babysitting, $11 per hour landscaping. Last week, Maya's earned a total of $96, worked 3 times as many hours babysitting as she worked landscaping. All right, we want to determine the number of hours that Maya worked babysitting last week and the number of hours she worked landscaping. All right, well, we have to make 2 equations to model what's going on. So she makes $7 per hour babysitting, and she makes $11 per hour landscaping. Change colors. And so that's what I have. And also, last week, Maya earned a total of $96 and worked 3 times as many hours babysitting as she worked landscaping. So what we have is, we'll start with the total amount of money that she earned. She earned $7 per hour. I'm going to let B represent the number of hours babysitting. Plus, she makes $11 per hour landscaping, so I'm going to say 11 times L has to equal $96, because that's how much she made in a week. So there's one expression that relates B and L together. They also tell us that Maya worked 3 times the number of hours babysitting as she did landscaping. So that means her babysitting hours is equal to 3 times the number of hours landscaping, 3 times L. So I have 2 expressions here that I want to solve. Well, algebraically, I'm looking to try to solve this, and since we already have an equation written as explicitly, in this case B equals, we're going to use substitution method. So we're going to start writing our equation over here, but where we see B, we're going to put 3L. So I have 7 times 3L, and then we have plus 11L is equal to 96, and then we're going to work our way and solve. So we have 21L plus 11L is equal to 96. Put those together, we got 32L is equal to 96. Divide by 32. And we get L is going to equal 3. So she works 3 hours landscaping. Now we go solve for B. Well, B, since it's equal to 3 times L, we'd go 3 times, and we got L to be 3. And so B is equal to 9. And then so we take these values and we put them back into context. So she was babysitting for 9 hours and landscapes for 3 hours. Okay, new problem. Abby and her kids went into a movie theater. She buys $71.50 worth of drinks and pretzels. All right, then they tell us that each drink costs $4 and each pretzel will cost $4.75. And she buys a grand total of 16 drinks and pretzels together. So a total of 16 drinks and pretzels. We need to write a system of equations for what's going on. Well, we're going to let, color code here, I'll let pretzels be P, and we're going to let drinks be capital D. So together, the number of pretzels and the number of drinks adds up to be 16. And we're also told that she spent $71.50, and that was when after buying however many pretzels and drinks. So each pretzel costs $4.75, and then plus, and then each drink costs $4, so 4 times D. And so we're going to work our way, and we're going to solve here. Now, we're going to take the easiest looking equation that we have, and we're going to write it explicitly. And the easiest looking equation we have is here on the left. And I'm going to say, let's just write this as P equals. So I'd subtract the D to the other side, and we'd have P is equal to 16 minus D. So there's an equation that I'm going to use. And I'm going to go over to my right-hand side, my right-hand equation, and I'm going to start writing it. But when I get to P, I'm going to input our equation. So our equation of 16 minus d is going there, and then we continue to write everything else. So that way we perform substitution. Now our equation's only in terms of one variable, and then we work our way to solve. So 71.5 is going to equal, we distribute the 4.75, and you use a calculator to do that, and we get 76 minus 4.75d plus 4d. Combine our like terms on the right, so we'll put the negative 4.75 and the 4d together, and we have 76. That leaves us with minus 0.75d. Subtract the 76 to the other side. We subtract the 76 to the other side, and we'd have negative 4.5 is equal to negative 0.75d, and then we divide. And that's going to give us what d is. And we wind up getting d to equal 6. All right, so d is 6. Now we go solve for p. Well, we already have an equation that is written as p equals, so we go p is equal to 16 minus what we just got for d, and d was 6. And we wind up getting p is equal to 10. So we get numbers for d and numbers for p. Now we got to take these numbers and we got to put them back in context. Well, p represents the number of drinks, or excuse me, p is the number of pretzels. So they bought 10 pretzels. And d is the number of drinks, so we'll say 6 drinks. All right, new problem here. Jake's working 2 summer jobs, makes $12 an hour landscaping and $16 per hour lifeguarding. In a given week, he can work at most 17 total hours and must earn at least $240. So we're going to have a system of inequalities here because of those key words that we're given, it says at most and at least. So it doesn't equal those two numbers necessarily. It could be greater than or less than, so we're going to have inequalities. So let's see what we can figure out here to start writing some equations. Well, Jake can work either of his 2 jobs, however much he wants, but together he can only work a total of 17 hours. I need to define some variables. So I'm going to let x is going to equal the hours landscaping. And y is going to equal the number of hours lifeguarding. All right, so now that we've defined some variables, we know that the number of hours in total, x plus y, has to be at most 17. Well, at most 17 means it has to be less than or equal to 17. And we also know that Jake is making $12 per hour x, so that's lifeguarding, plus the $16 per hour lifeguarding y has to be at least $240, so that's going to be greater than or equal to 240. So we have our 2 equations. Now we want to figure out how to proceed. And so that takes us to this next part. Jake worked 3 hours of landscaping. Now I want to determine all the possible number of whole hours. Determine all the possible values for the number of whole hours lifeguarding that he must work to meet the requirements of these 2 inequalities. Okay, well, if he worked 3 hours landscaping, we're given, see, landscaping is x. We know that x is equal to 3 for both of these problems. So what we're going to do is we're going to put in 3 into both of our inequalities, and then we're going to start working our way to solve for y. So I'll start here on the left-hand side. We minus the 3 to the other side. We get y is less than or equal to 14. So there's one scenario. Now I do the same thing for my equation on the right. So 12 times 3 plus 16y is greater than or equal to 240. So 36 plus 16y is greater than or equal to 240. We're going to minus the 36 to the other side. and that gives us 16 times y is greater than or equal to 204. And then from here, we're going to divide by 16. So we divide by 16 on both sides, and we get y must be greater than or equal to, well, 204 divided by 16, and it winds up being a decimal, 12.75. All right, so we have to pick hours, whole number hours for y that meets both of those requirements that were given. Less than 14, greater than 12.5. Let's look at this on a number line. So we have 12.75, and we have 14. And we got to find the hours that meets, the whole number of hours that meets those requirements. So basically, I have to be inside of here, but I could also include the 14 because it's a whole number hour. So our possible number of hours for lifeguarding would be 13 hours or even 14 hours. But he couldn't go anywhere outside of that range. Okay, last problem here. Ben and his children went into a bakery where they sell donuts for $1.25 a piece and cookies for $0.25 a piece. Ben has $5.50 to spend and must buy a minimum of 10 donuts and cookies altogether. Okay, so we'll let D represent the donuts and C will represent the cookies. Now, the number of donuts and cookies together, he has to buy a minimum of 10. So that means they have to be greater than or equal to 10 when I add their numbers together. Now, the next part we look at is the financial piece, which deals with the cost. So a donut costs $1.25, so $1.25 per donut, so 1.25D, plus 0.25 times C is going to be my cost. Now he has a total of $5.50 to spend, so that would have to be less than or equal to $5.50. We'll say 5.5. Now we look at the next part. They're going to give me a condition here, and it says that Ben decided to buy 2 cookies. Okay, well, we're told that C is equal to 2. And so if C is equal to 2, we're going to put in 2 into both of our equations and then see if we can solve for D and come up with numbers that will work. So if I put in 2 into my first equation, so D plus 2 must be greater than or equal to 10. Subtract the 2 over. The number of donuts has to be greater than or equal to 8. All right, so he has to buy at least 8 donuts. That's what the first inequality says. All right, our second expression, we put in 2 for the C, 1.25 times D, plus 0.25 times C, but C is 2, has to be less than or equal to $5.50. Well, 0.25 times 2 is 0.50. So we have 0.5 less than or equal to 5.5. Well, let's minus the 0.5 from both sides. And we get 1.25 times D is less than or equal to 5. Now, let's divide both sides by 1.25 so we can see what this inequality says about our D value. So 5 divided by 1.25 says that D has to be less than or equal to 4. Okay, well, we look at our 2 conditions. We're trying to find the maximum number of donuts that Ben could buy and have this be true. Well, I'm going to look at this on a number line again. Okay, so our first inequality says that D has to be bigger than or equal to 8. So it has to be bigger than or equal to 8 this way. Our second inequality, D has to be less than or equal to 4, so 4 is over here, said I could buy 4 donuts or I'd go this way. The issue that we have is they don't overlap. There's no area that fits in both of these shaded regions. I can't be less than or equal to 4 and greater than or equal to 8 at the same time. And so this problem here is actually, we have no solutions. It's not possible for him to buy donuts and cookies with these given conditions.